All right, hello. I'm Chris Wraith. I'm the engineering director at Elastic Path. We're an e-commerce company. What we do is try to make sure that our customers can build really awesome e-commerce experiences. Before that, I worked in financial services for a while. And in my free time, I think I would describe myself as a domestic Raspberry Pi nerd. So I'm going to talk to you a little bit today about why you might want to put Kubernetes on a Raspberry Pi. So why on earth would you want to do this? Well, for me, learning and experimentation is a really big and important part of this. You want to be able to do this at low cost. So anybody here who's used Kubernetes for work, particularly in public cloud providers, will know that as soon as you start adding those resources, the cost starts to ramp up. You can easily be looking at $100 a month for a very basic cluster, which, if you're learning this on your own time, or if you're trying to do some experiments on, to see what you can do with it, this is perhaps not something you want. If you're running these all the time, then the power is expensive in 2024. Electricity's got a lot more expensive in the last 20 years. So these use very little power. You can run them all the time, and it's not going to break the bank with your electricity bill. We'll also talk about performance needs, because realistically, your performance needs to be modest, but we'll cover that Raspberry Pis have got a lot more capable in the last couple of years. Who remembers one of these? So this, the amount of compute that was available in one of these is, this was fairly standard in about 2001, is kind of available at a much lower cost now in one of these with the right extensions, shall we say. Raspberry Pi is now in its 5th generation. And as a piece of hardware, they're fairly well specified. This is from the Raspberry Pi website. So this is the Raspberry Pi 5. It comes with a 4-core ARM processor. It's looking at about 2.4 gigahertz of clock speed. You can get them in 2, 4, and 8 gigabyte memory variations, which you can run some. If you look at the top spec for those, you could run some fairly reasonably sized apps on it. Key thing with the Raspberry Pi 5 is that you get access to the PCIe bus. This is important because that means you can plug an SSD into it, which means that your storage then is fast as well. One of the previous problems we've had is choosing the right SD card is really important here. If you notice here the little 3 there that's pointed out, if you're choosing a card, you probably want one with the 3 in that box. That's going to give you the maximum read and write throughput. I've found brand matters as well, if you test them out individually. These ones, the SanDisk Extreme Pros, have worked the best for me. Your mileage may vary, but you can get about 200 megabytes per second out of these. But what you really want is this, if you want fast storage speed. So this is plugged directly into the PCIe bus. You've got an SSD directly in there, and you're going to get way, way faster read and write speeds with that. This is kind of the state of the art. If you were choosing to build a cluster from scratch, this is the way you would want to go. You'd also want as much memory as is humanly possible, and as much storage as is required for your application. So how do you actually go about doing it? Well, firstly, procure some Raspberry Pis, best spec that you possibly can. You're going to need to network them together. You can use wireless for this. You probably want to use wired. You don't want to have a bottleneck in your performance anyway if you can avoid it. If you look at the QR code there, that's just a link to a gist which actually shows you, it's ostensibly a shell script which will show you how to do this on a Raspberry Pi. The too long didn't read is you need to enable C groups. This is just a firmware piece that allows Kubernetes to work. You are going to want to disable the swap file. The last thing you want if one of these nodes is running out of memory is to be thrashing against the disk because you've run out of memory. You're going to use the regular app packages to install kubadmin, kubectl, kubelet, containerd, and a few other supporting packages. You're going to configure the networking. You're going to bootstrap the control plane, and then that's going to give you a bare metal cluster. One of the things you realize about cloud providers is they give you all of the cool stuff in there already. So you're going to have a CSI driver. So when you create your persistent volume claims, they're going to give you volumes. You're going to have a networking provider, a CNI setup. You're going to be able to get in routing-wise. You're going to have a load balancer that's going to let you get in there as well. So these are all things you have to do yourself when you do it bare metal. The great thing about that is it's going to teach you a lot about how clusters work. It's going to give you that mechanical sympathy that perhaps is, is really necessary for us. So try it out, see how it works. Buy a console cable. You might need to debug things, back things up if you rely on it. Should I do it in production? Probably not yet, but maybe one day. Thank you very much.
Thank you very much.